In this video, I will show you how to determine the solution set of an absolute value equation in one variable, particularly on equations that involve absolute value expressions in each side of the equation. Let us start with the absolute value of 2x plus 5 minus 4 equals the absolute value of x minus 3 plus 8. To solve this, let's start with the first case. That is, we assume that 2x plus 5 is greater than or equal to 0 and x minus 3 is greater than or equal to 0. To solve this, let us recall that the absolute value of x is equal to x if x is greater than or equal to 0 and it is equal to negative x if x is less than 0. Following this definition, we can write the equation as 2x plus 5 minus 4 equals x minus 3 plus 8. Simplifying this, we'll get 2x plus 1 equals x plus 5, and combining similar terms, we'll have 2x minus x equals 5 minus 1, which results to x equals 4. To determine whether 4 satisfies the given equation, we can check it in different ways. Let's have the first one. First, we can check for x equals 4 by substituting this value in the given equation. Doing that, we'll have the absolute value of 2 times 4 plus 5 minus 4. Is this equal to the absolute value of 4 minus 3 plus 8? Simplifying each side, we'll get the absolute value of 13 minus 4. Is this equal to the absolute value of 1 plus 8? Simplifying further, we'll get 13 minus 4. Is this equal to 1 plus 8? Lastly, we'll get 9 equals 9, which is a true statement. Therefore, 4 is a solution. Another way of checking whether 4 is a solution is by solving the compound inequality that we've had in our assumption. Going back to that, we have assumed that 2x plus 5 is greater than or equal to 0 and x minus 3 is greater than or equal to 0. What we're going to do is to solve this compound inequality that involves the word and. Let's start with 2x plus 5 greater than or equal to 0. Solving this, we transpose 5 to the right side. It becomes 2x is greater than or equal to negative 5. Solving for x, we can divide both sides by 2, or we can multiply both sides by 1/2. That will result to x is greater than or equal to negative 5 over 2. Writing this in interval notation, we'll get the interval from negative 5 over 2 to infinity. Solving the other inequality, we have x minus 3 is greater than or equal to 0. Transposing negative 3 to the right side will result to x is greater than or equal to 3. Writing this in interval notation, we'll have the interval from 3 to positive infinity. Since the compound inequality involves the word and, then we need to get the intersection of these solution sets. So the intersection is the interval from 3 to infinity. So to check whether 4 is a solution, we just need to check whether 4 belongs to this interval. And obviously, 4 is in the interval from 3 to infinity, thus 4 is a solution. For case number 2, we now assume that 2x plus 5 is greater than or equal to 0 and x minus 3 is less than 0. Again, by following this definition, we can write the equation as 2x plus 5 minus 4 equals the negative of the quantity x minus 3 plus 8. Simplifying each side, we'll get 2x plus 1 is equal to negative x plus 3 plus 8. Simplifying further, we'll have 2x plus x equals 11 minus 1, which results to 3x equals 10. Solving for x, we can divide both sides by 3, or we can multiply both sides by 1/3. This will give us x equals 10 over 3. So to check whether 10 over 3 is a solution, we can make use any of the two methods that were presented in the previous slide. In this example, I will be using the first method. So let's check for x equals 10 over 3. Substituting this value in the equation, we'll have the absolute value of 2 times 10 over 3 plus 5 minus 4. Is this equal to the absolute value of 10 over 3 minus 3 plus 8? Simplifying each side, we'll get the absolute value of 35 over 3 minus 4. Is this equal to the absolute value of 1/3 plus 8? Next, we'll get 35 over 3 minus 4. Is this equal to 1/3 plus 8? Simplifying each side, we'll have 23 over 3 equals 25 over 3, which is a false statement. Therefore, 10 over 3 is not a solution. For case number 3, we now assume that 2x plus 5 is less than 0 and x minus 3 is greater than or equal to 0. By following this definition, we can now write this equation as the negative of the quantity 2x plus 5 minus 4 equals x minus 3 plus 8. Simplifying each side, we'll get negative 2x minus 5 minus 4 equals x plus 5. Next, we'll have negative 2x minus 9 equals x plus 5. Transpose x to the left side and negative 9 to the right side. This will give us negative 2x minus x equals 5 plus 9, which results to negative 3x equals 14. Dividing both sides by negative 3 or multiplying both sides by negative 1/3 will give us x equals negative 14 over 3. So next, we now check if negative 14 over 3 is a solution. So checking for x equals negative 14 over 3. Substituting this value in our equation, we'll have the absolute value of 2 times negative 14 over 3 plus 5 minus 4. Is this equal to the absolute value of negative 14 over 3 minus 3 plus 8? If we simplify each side, we will get the absolute value of negative 13 over 3 minus 4. Is this equal to the absolute value of negative 23 over 3 plus 8? Simplifying further, we'll have 13 over 3 minus 4. Is this equal to 23 over 3 plus 8? This will give us 1/3 equals 47 over 3, which is a false statement. Therefore, negative 14 over 3 is not a solution. For the fourth case, we now assume that 2x plus 5 is less than 0 and x minus 3 is less than 0. So again, if we are going to follow this definition, we can write this equation as the negative of the quantity 2x plus 5 minus 4 equals the negative of the quantity x minus 3 plus 8. Simplifying both sides, we'll get negative 2x minus 5 minus 4 equals negative x plus 3 plus 8. Simplifying further, we'll get negative 2x minus 9 equals negative x plus 11. So now we transpose negative x to the left side and negative 9 to the right side. That will give us negative 2x plus x equals 11 plus 9. Simplifying this, we'll have negative x equals 20. So solving for x, we can multiply both sides by negative 1 or we divide both sides by negative 1. That will result to x equals negative 20. So checking whether negative 20 satisfies the equation or not, we substitute negative 20 to the equation. That will give us the absolute value of 2 times negative 20 plus 5 minus 4. Is this equal to the absolute value of negative 20 minus 3 plus 8? Simplifying each side, we'll have the absolute value of negative 35 minus 4. Is this equal to the absolute value of negative 23 plus 8? Next, we'll get 35 minus 4. Is this equal to 23 plus 8? Simplifying each side, we will get 31 equals 31, which is a true statement. Thus, negative 20 is a solution. In summary, the solutions of the given absolute value equation are negative 20 and 4. Thus, the solution set will be the set containing negative 20 and 4.